In this video, we're going to talk about hyperbolas. A hyperbola is a shape that can be generated from a cone, and so it's called a conic section. I want to read the definition with you, and then we'll draw a couple pictures just to make some sense out of what's here for the definition, and then we'll try to connect this with the formula for the hyperbola. The hyperbola is the set of points in a plane, the difference of whose distances from two fixed points, the focus points or the foci, is constant. Okay, and then so before we go any further, let me kind of give you a couple of pictures to get an idea of what this looks like. First of all, this is a conic section, and we get a hyperbola from a double cone. So if we were to draw two cones sort of balancing on top of each other, they should be equal at the top and the bottom. If we were to take a slice kind of vertically through the two of them, we would get a shape on either side, and those two curves together make a hyperbola. Okay, so I want to take a second and draw a hyperbola with you and kind of try to talk about these distances that are mentioned and kind of label it so that we can connect it up with the formula that we're going to see in a second. Okay, so a hyperbola can be horizontal, kind of have the two arcs going left to right, or it can be vertical with one at the top and one at the bottom. I'm going to draw this one horizontal. So if it's horizontal, then we're going to have, well, let's see here. We're going to have two curves, but before I draw the curves, the way we usually draw this is to draw a little dotted box to help us. Okay, so just like for the ellipse, we're going to have an A, and that A, if it's horizontal, will be on the, for us, it'll be on the x-axis. This is not called the major axis like it is for the ellipse. For the hyperbola, it's called the transverse axis, and it would connect these two innermost points. I think it's called transverse because it really cuts the shape in half. It kind of goes right across the middle of the shape. Okay, to draw it, we usually mark off the values for A on either side on the transverse axis, and then the values for B on what maybe could be called the minor axis for this one. I like to draw in this dotted box. Okay, so that gives us a good way to get some guiding lines drawn really easily. So I draw this box. Note that the B is really not going to touch the shape, but the hyperbola is, if it's horizontal, it's sort of like a sideways parabola kind of shape. It's not exactly the same shape as a parabola, but it sort of has that same feel to it. The hyperbola has an asymptote that it approaches at the ends of each curve. So the hyperbola will approach the asymptote, and the asymptote is the diagonal through this box. So by drawing the box, it makes it a little easier to identify where the asymptote would be without plotting a whole lot of points. So the asymptote is going to go through the center and to the corners of the box. Okay, and so then I have a curve that comes out from the vertex towards the asymptote. And this one is horizontal. Okay, for a hyperbola, the focus points are outside of the vertices, but inside these two curves. So they are still on the same axis, if you want to think of it like the major axis. They're still on that same line, okay, but inside of these curves. Okay, so let's go back to the definition for a second. It says the hyperbola is the set of points in a plane. So again, that just emphasizes that this is a two-dimensional shape. The difference of whose distances from two fixed points is constant. So if I were to pick a point on the hyperbola, let's say I picked this point, and I measured the distance from this focus point, and then I measured the distance kind of all the way across to this focus point, this is saying that I could subtract these two distances. Since the way I have it, distance 2 looks longer. We'll say distance 2 minus distance 1 is a constant. So I could move to another point on the hyperbola and it should obey the same relationship, right? Or a point down here or on this curve. Anywhere on the hyperbola should should maintain this. Okay, so now let's kind of connect that with the equation. So again, we're going to look only at hyperbolas centered at 0, 0. We could shift these left or right, up or down, and that would change the center, but we're always going to be counting from the center. So since we're starting out, we're just going to look at those that are centered at 0, 0. Okay, for the hyperbola, the way we decide horizontal or vertical is a little bit different. Notice the equation still has the x squared and the y squared, but in the middle we're subtracting. And so that's what makes this formula different from the ellipse, is the subtraction. So if it's a plus, it's an ellipse. If it's a minus, it's a hyperbola. We use what's listed first to decide whether it's horizontal or vertical, not which number is bigger on the bottom. So it's different than an ellipse. When I'm subtracting, the order matters. And so what's listed first now makes a difference. If I'm adding, I can always rearrange the order. And so that doesn't really make a difference. Okay, so since the x is listed first, that means that my hyperbola is going to be on the x-axis, or it's going to be horizontal. Okay, let's see. So these are all of the labels for the things we just drew. Let's start with the vertices, and we'll save the asymptotes for last. So the vertices, we said, are the points right here on that transverse axis. The focus points are going to be outside of the vertices, but inside the curve. Since the value for C is bigger than the value for A, this time C squared is A squared plus B squared. So I get a number bigger than A, which will be inside the curve. Notice there's nothing listed here for the B at the moment because we don't have any points at B or negative B like we did for the ellipse. But the B does play a part in the asymptote. So when I draw the diagonal through this box, this imaginary box, it might be important to note that all these dotted lines are not technically part of the curve. They're just drawn there to help us draw the actual hyperbola. But the asymptote that we've drawn here goes through from 0, 0 through this point, which would be A, comma B. So the rise would be B, and the run would be A. And so that gives us the asymptote, right? Rise over run. We have one that's going up, with a positive slope, and then we have one that's going down from left to right with a negative slope. Okay, and then if we were to change that to a vertical transverse axis, so maybe take this picture and flip it up 90 degrees, so we'd have a curve up here and a curve down here. Notice for the vertical, the y comes first, so that tells us that the value for a would be here, and the value for negative a here, and these would be the b and the negative b. And we basically are saying the same things here, we've just kind of taken this shape and rotated it. So the rise over the run is different. The vertices are on the different axis, so I have y values here of a. The focus is going to be on the same axis as the vertices, and this relationship for the C is the same. All right, so let's take a minute and try to graph a hyperbola. I've got a whole lot more on the page here, so I'm going to go ahead and tell you this time that this one is horizontal. Right, remember, we just said this several times, but the way we can tell is what is listed first. Since the x is listed first, that's going to make this a horizontal parabola. I'm sorry, a horizontal hyperbola. Okay, so notice that the a is always going to be under what is first. So a squared is 4, which means that a must be 2. B squared is 9, which means that b must be 3. And c squared is a squared plus b squared. Remember, c is bigger than a, so when I add b squared, I'm going to get something bigger. So c squared is 4 plus 9. Okay, and we're going to need to know what that's equal to. Let me scoop this up. So let me try to do this again on my calculator. I'll try not to be as slow this time. So that's about 3.6 or 3.61, somewhere in there. Okay, so let's draw this. Okay, first, notice that the A is on the x-axis, right? It's horizontal, so the A is 2. 1, sorry, let's label these. 1, 2. And the B is 3. I don't usually use a dot for the B, I usually use an X because it's not actually part of the graph. Okay, and then to make the asymptotes, we're going to draw in that dotted box. And then we're going to draw the diagonals of this box through the center. Those will be the asymptotes. And now the curve, this is a very wide hyperbola. It's going to approach those lines on either side. Okay, And the focus points, like we said, are within these curves, but outside of A. So 1, 2, 3.61 maybe is about right there. And 1, 2, 3, negative 3.61 about right there. All right, so let's list some of the important parts of this. So the vertices are at 2, 0 and negative 2, 0. The foci, or the focus points, are at, and just like we said before, you could put 3.61 here or the square root of 13. I'm going to go ahead and put the square root of 13 this time, but I think either would be just as good. Notice those are on the same axis. Okay, and then we need the asymptotes. These are an equation of a line, so it'll be y equals, and we're going to do the rise over the run, so 3 over 2 x and negative 3 over 2 x. All right, so this is a hyperbola. Let's try one more. Okay, so the question for you is this one horizontal or vertical? Notice the y comes first, so this one is vertical, which means that that 4 is a squared. So a would be 2. And the 25 is b squared. So b must be 5. And c squared is a squared plus b squared. So 4 plus 25. So I'm going to take the square root of 29, and I get 5.39, let's say. Okay, so let's draw this. It's vertical. Here's our x and y. So we need to put our point at 2. A is 2 on the y-axis, and at 0, negative 2. And then b is 5 on the x-axis. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Then we want to draw our dotted box around those. Okay, and then we want to draw the diagonals through those dotted boxes. All right, and now we can draw the hyperbola. Remember, it's vertical, so we've got 1 at the top here. Sort of looks like this, and 1 at the bottom. And the focus points are inside, So the focus point here is at 5.39, so 1, 2, one, 2, 3, 4, 5, whoops, it's kind of off the graph, put it right there, and same down here. Alright, so now let's list out some of these points. So the vertices are at 0, 2, and 0, -2. The foci are at 0, square root of 29, and 0, negative square root of 29. And then the asymptotes again, we want to measure the rise over the run. So we're rising 2 and running 5. So we've got y equals 2 over 5x, and y equals negative 2 over 5x. Well, I hope this gave you a really good idea of what a hyperbola looks like, how to make its graph, and how to connect that up with the equation. Good luck practicing this, and we'll see you in the next video.